You are sitting at a red light in rush hour traffic. The light turns green, you take your foot off the brake, and you press the gas pedal. But instead of moving forward, your car shudders, the dashboard flickers, and the engine has to physically crank itself back to life before you can even move an inch. By the time your car wakes up, the guy behind you is already honking his horn. Automatic engine start-stop systems are marketed as the ultimate way to save fuel and cut down on emissions, but the truth is, this feature is completely destroying your engine from the inside out. When your engine is running, the internal components like the crankshaft and camshaft are floating on a thin, highly pressurized layer of oil. This is called hydrodynamic lubrication. The metal parts never actually touch each other, but the second that start-stop system shuts the engine down at a red light, that oil pressure drops to zero. The oil drains back into the pan, and the heavy metal components rest directly on their bearing surfaces. When the light turns green and the engine fires back up, you get a split second of direct metal-on-metal friction before the oil pump can build pressure again. Doing that once or twice is fine. Doing it 40 times a day on your daily commute adds up to massive bearing wear. On top of that, these systems put a ridiculous strain on your electrical system. Your starter motor is working overtime, and to handle the constant power drain, manufacturers have to use massive heavy-duty AGM or EFB batteries. When that battery eventually dies, and it will die about 40% faster than a normal battery, you are not paying $80 at the auto parts store anymore. You are looking at $250 to $300 just for the battery replacement. The fuel you save at the pump is entirely wiped out by the premature wear on your starter, your battery, and your engine bearings. These systems were built to help car manufacturers pass strict government emissions tests, not to save you money. And if we are talking about saving fuel, we have to talk about cylinder deactivation. This is a feature heavily pushed on big V8 engines, like what you find in a Chevy Silverado or a Ram HEMI truck. The idea sounds great on paper. You are cruising down the highway at a steady 65 miles per hour, and the computer shuts off 4 of the 8 cylinders to save gas. It does this by using specialized hydraulic lifters that collapse and stop opening the intake and exhaust valves. But here is the reality of the situation. Those collapsing lifters are incredibly sensitive to oil quality and pressure. The tiny locking pins inside them get gunked up with carbon and oil sludge. When they fail, and they fail constantly, they get stuck. The lifter starts slamming against the camshaft instead of riding smoothly on it. Before you know it, you have a misfiring engine, metal shavings in your oil pan, and a completely wiped-out camshaft. What started as a clever way to squeeze an extra 1 or 2 miles per gallon out of a big heavy truck turns into a $4,000 top-end engine rebuild. An engine runs best when it is balanced and consistent. Turning cylinders on and off creates uneven thermal expansion, weird harmonic vibrations, and oil consumption issues. The math just does not work out in your favor. If you want to protect your wallet from these engineering disasters and learn how to actually keep your car running forever, hit that subscribe button right now. I share these garage realities so you do not end up stranded or broke, and you definitely want to catch the next video. Now, let's talk about the transmission that is probably attached to that engine. For decades, we had traditional automatic transmissions with actual gears, but now, almost every economy car, from the Nissan Altima to the Honda Civic, uses a CVT, or continuously variable transmission. Instead of physical gears, a CVT uses a heavy-duty steel belt running between 2 adjustable pulleys. As you accelerate, the pulleys change size to keep the engine in its most efficient power band. That is why a CVT feels like a rubber band when you step on the gas. The engine just drones at a constant speed while the car slowly catches up. To make them feel less weird, manufacturers program fake shift points into the computer, which completely defeats the purpose of the infinite gear ratios. But the real problem is durability. That metal belt is under immense friction. If the transmission fluid gets even slightly dirty, or if you overheat the unit by carrying too much weight, the belt starts to slip. When steel slips on steel, it scores the pulleys and creates metal glitter that destroys the entire valve body. You usually cannot just rebuild a CVT in your driveway or even at a local transmission shop. They are often sealed, non-serviceable units. When it fails, you are on the hook for a completely new unit, which can easily cost you north of $3,500. Another massive modern failure point is the electric water pump. Back in the day, a water pump was a simple mechanical device driven by a rubber belt connected to the engine. When the bearing started to go bad, it would give you plenty of warning. It would squeak, or it would leak a little bit of green coolant from a tiny weep hole onto your driveway. You knew you had a few weeks to get it fixed. Modern cars, especially European models like the BMW 3 Series, use electric water pumps. They do this to reduce parasitic drag on the engine and to keep coolant flowing through the turbochargers even after you turn the key off. But here is the fatal flaw. They provide zero warning before they fail. These pumps rely on plastic impellers and a complex electronic circuit board bolted right to the side of a screaming hot engine block. Heat and electronics do not mix. When the circuit board fries from voltage spikes or pure heat soak, the pump just stops dead. Your engine is no longer circulating coolant, and because there is no belt to squeal, you have no idea it happened until the red temperature warning lights up the dashboard. By the time you manage to safely pull over to the shoulder of the highway, your aluminum cylinder head is already warped from the extreme heat. A failing electric water pump does not just cost you a tow truck and an $800 replacement part, it often takes the entire engine down with it. I am about to break down a luxury suspension system that will literally strand you on the asphalt and drain your bank account faster than anything else on the car. But before I reveal this massive money pit, make sure you hit that subscribe button. You need this information to avoid buying a used car that will bankrupt you. Alright, let's talk about air suspension. You find air suspension on high-end luxury SUVs, Range Rovers, and Mercedes sedans. Instead of a solid steel coil spring, the car rides on rubber bladders filled with highly pressurized air. It feels like you are driving on a cloud. It is incredibly comfortable, but rubber degrades. The road salt, the freezing winter temperatures, and the brutal summer heat cause that rubber to dry rot and crack. Eventually, a microscopic pinhole leak develops in one of the air struts. You might not even notice the car sagging at first, but your car's computer notices. To keep the ride height level, the computer commands the electric air compressor located in the trunk to turn on and pump more air into the leaking strut. That tiny compressor is designed to run for a few seconds at a time. It is not designed to run continuously. Because of that tiny leak, the compressor works overtime, overheats, melts its internal piston rings, and completely burns out. So now, instead of just replacing one leaking air strut, you have a completely collapsed suspension. The car is sitting on the bump stops, so you cannot even drive it onto a tow truck easily. And you have to replace the air strut, the compressor, and usually the control valve block. A simple rubber crack turns into a cascading failure that creates a repair bill well over $2,500. While we are talking about air pressure, let us talk about the tires. The Tire Pressure Monitoring System, or TPMS, is a great safety idea in theory, but in practice, it is a massive source of stress for drivers. The system relies on little battery-powered sensors inside the wheel, attached to the valve stem. Here is the annoying part. Those sensors are incredibly sensitive to temperature changes. Cold air is denser than warm air. As a rule of thumb in the garage, for every 10 degrees Fahrenheit the temperature drops outside, your tire pressure drops by 1 psi. So when that first freezing morning hits in November, your tire pressure naturally drops a few psi, and the warning light immediately illuminates on your dashboard, making you panic that you have a flat tire on the way to work. Even worse, the non-replaceable batteries inside those sensors only last about 7 to 10 years. When the battery dies, the whole sensor has to be replaced, which means taking the tire off the rim, installing a new $50 sensor, rebalancing the wheel, and using a specialized scan tool to introduce the new sensor to the car's computer. The aluminum valve stems on these sensors also notoriously corrode and snap completely off when you just try to add air at the gas station. You are much better off ignoring the fickle dashboard light and just keeping a reliable manual tire pressure gauge in your glove box, checking it yourself once a month. Let's shift to something that used to be incredibly simple but has been ruined by technology: the parking brake. It used to be a steel cable connected to a handle. You pull the handle, the cable physically pulls the brake pads against the rotor, and the car stays put. Simple, reliable, and you could fix it yourself. Now, almost every car has an electronic parking brake, or EPB. You push a little plastic button on the center console, and an electric motor mounted directly on the rear brake caliper whirs loudly, pads down. Car designers did this just to free up space in the center console for bigger cup holders and wireless phone chargers. But they made basic maintenance a nightmare You cannot just unbolt the caliper and push the piston back in to change your brake pads anymore. If you try, you will destroy the electric actuator motor. You now have to plug a bidirectional OBD2 scan tool into the car and command the computer to put the brakes into service mode to retract the piston electronically. If you do not have that expensive tool, you cannot change your own brakes. Even worse, if your car battery dies while the electronic parking brake is engaged, you cannot release it. The car is totally immobilized. You cannot even drag it onto a flatbed tow truck without dragging the locked rear tires across the pavement. Finally, let us look up at the roof. Panoramic glass roofs are a huge selling point on the showroom floor. They look amazing, making the cabin feel open and spacious. But they are a terrible idea for long-term ownership. First, they let in a massive amount of radiant heat. Even with the thin, flimsy mesh sunshades closed, the glass turns the interior of your car into a sauna on a sunny day, forcing your air conditioning system to work twice as hard to keep you cool. Second, they are incredibly heavy. You are putting 150 pounds of glass at the absolute highest point of the vehicle. This completely ruins the center of gravity, making the car handle worse in corners and increasing the risk of a rollover. You are replacing a solid sheet of ribbed steel with a fragile pane of glass. If the car does roll, that glass shatters instantly, offering zero structural support and raining sharp debris into the cabin. And when it comes to maintenance, the tracks require constant lubrication, and the drain tubes meant to channel rainwater away inevitably get clogged with dirt and pine needles. When those tubes clog, the water overflows directly into your headliner, running down the interior pillars and soaking your floorboards, which usually fries the main wiring harnesses hidden under the carpet. When the glass itself cracks from a stray rock on the highway, it is a highly specialized, very expensive repair that requires cutting out the old heavy panel and perfectly sealing a new one so it does not leak or squeak over every bump. Automotive engineering has given us some incredible advancements, but a lot of these modern features are just complex solutions looking for a problem. They add weight, they add cost, and they make it nearly impossible for the average owner to maintain their own vehicle without specialized computer tools. I want to know what you are dealing with in your own garage right now. Drop a comment below and tell me your car's make and model, what kind of weird check engine codes you are fighting, or if you have a trick for improving your MPG. Let's get a conversation going and solve some of these mechanical mysteries together. And if you learned something new today, make sure you hit that subscribe button, give the video a like, and keep those engines running strong. Catch you in the next one.